Hey everybody, today we're going to learn about molar heat or enthalpy of solution. Okay, so first we have to talk a little bit about this term heat. Okay, when you think about the word heat, you think hot, but not everything in chemistry always gets hot. So they use this scientific term enthalpy to kind of remove any of the warm connotations. So enthalpy has an H in it, so they talk about the change in enthalpy, the change in heat, the change in energy of your solution. Okay, so what you'll see down here is this delta H SOLN for solution is the amount of heat energy absorbed or released when 1 mole, because everything's based off of a mole, of a solute dissolves in a specific amount of solvent. And then this is where we get whether we have our endo or exothermic reactions, which is what we were talking about in the very beginning of all of these videos. Okay, so endothermic means that there is going to be a positive heat change. Okay, that means it is going to absorb energy. So if it absorbs energy, it needs to be in the reactants portion of the reaction. So here we have our reactants, our yield sign, and these are our products. Okay, so delta H will be positive. Now, if you are exothermic, you have a negative heat of solution. That means it is going to release energy from the system into the surroundings. So if it releases, you're going to see your heat as a product. Okay, the reactants, okay, will not need any additional heat in order to happen. So here you'll see the delta H is negative, and up top for the endothermic one, the delta H will be positive. Okay, so negative is exo, positive is endo. All right, so what are some examples of our endo and exothermic reactions? All right, it's obviously a chemical reaction when we have an instant ice pack. Okay, you've all probably used them. Okay, it's not always going to be cold, but there is a small amount of ammonium nitrate inside the packet, inside one little vial, and then there's another big bag right there. And when you pop the one, these two mix together and absorb heat. When they absorb heat from the surroundings, it's going to feel cold to the observer. Okay? It is adding heat in order to get them to dissolve. All right, and then you see that we have our aqueous reaction on the other side. You have your ammonium ion and your nitrate. Okay, so you have your cold packs, you have to break mix, and get that to feel nice and cold. Okay, an exothermic reaction is just the opposite. Okay, endo-exos are opposite. So exo, you are going to see, come on over here, you are going to see that they are going to release the heat as a product. Okay, they used to make calcium chloride or magnesium sulfate packets that were very similar to what you see for your cold packets, but they're no longer like massively produced. They are still used in hospitals. Right, my father used one when he fell and hurt his back and broke his hip. So he was getting some pain relief and stuff like that with the warm packs, and it's calcium chloride or magnesium sulfate that then gets dissolved, and then you get your calcium 2 plus ion and your 2 Cl minuses, or your Mg2 plus and SO4 2 minus. But the big thing is that you are releasing heat, and that's why it's going to feel hot. Okay, what you're probably more familiar with is going to be the hand warmers. They're not instant, but if you go to football games or skiing or different kinds of bonfires and stuff like that, what the reaction is there is that they have very, very fine powdered iron. and you have to open it up, expose it to the oxygen in the air. And then what happens is it rusts. Yes, ladies and gents, this is the power of rust. So when it's all done, it's very hard. Okay, and that hard is when that hard metal is going to be the rust that remains. So in class, I always take one apart after it's been used, and you can see exactly how it happens. All right, so let's figure out one of these problems. One of these problems is going to look like this. All right, if 73.5 grams of sodium hydroxide is dissolved in 800 milliliters of water, how much heat is given off to the water? Okay, and our heat of solution is going to be negative 445.1 kilojoules per mole. And then it says to write a thermochemical equation for them as well. All right, so very important to know, sodium hydroxide is NaOH. Of course, we know our ions. Okay, the thermochemical equation is going to show that the delta H is going to be negative. Okay, so negative means it's going to be exothermic, and if it's going to be exothermic, the heat is going to exit. So that means it is going to be a product. Okay, so we have NaOH, okay, which is the solid, in conjunction with water, is going to produce Na plus and OH minus, and it's going to make negative 445.1 kilojoules. Very important that you put a negative sign there. And that's going to show exactly how much we make. This negative sign tells you that it goes on the right-hand side, but when you actually have your problem, this disappears. So you're going to take and make sure that that just shows you to put it on the right-hand side. It will release that 445.1. It doesn't make negative energy. Okay, and then when we are solving this, we plug it into our Q equals M delta H of, let's see, this is a solution reaction like we saw from chapter 10. And we have to make sure all of our units are going to work out. Okay, so as always, we have to make sure that we are in the right units. If this is in kilojoules per mole and it gives us grams of our sodium hydroxide, well, we need to convert 73.5 grams of NaOH. Use my dimensional analysis. 40.00 grams of NaOH from the periodic table, that's its molar mass, is 1 mole. And then lastly, I plug in my negative 445.1 kilojoules per 1 mole, and I get grams and grams to cancel out. I get my moles and moles to cancel out. Go and grab a calculator, and I get negative 818 kilojoules of energy that will be released. So how do I know it's released? Because it's negative, and it is exothermic, and it is a product. Okay, so here we have everything all broken up for us. Notice again, very importantly, right here, very importantly right here, it is not a negative sign when we are talking about our products. For some reason, no other color wants to work right now. There we go. Okay, so this is not negative. Okay, the negative sign only tells you what side it goes on. It is a product. And here we see our grams cancel out, our moles cancel out, and we get our 818 kilojoules added to the water. So the water will heat up. Okay, that is our thermochemical equations.